Hey y'all, Nick here. I'm super excited about this new series that we're putting together called Introduction to Smart Contract Development on Ethereum. So what we're going to do is we are going to switch gears a bit. We have a series out there on some of the front-end development. What we're going to do is look at some of the back-end development and how do we create programs for the Ethereum blockchain and interact with those programs, deploy those programs, test those programs. So we're going to take you through the whole journey from really starting out with some core concepts, some core kind of fundamental concepts that we need to understand in order to progress into actually developing software for Ethereum. So I'm going to try to make these videos as bite-sized as possible. I'm trying to stick within that kind of 15-minute time frame for each video. And the goal here is I'm going to continuously add to this presentation as we progress through the curriculum. So this presentation I will link in the notes below. Also, if you're enjoying this content, if you have any comments on how I can improve, please like and subscribe. And I'm really hoping to build more of this content over the next couple of months. All right, guys, so let's go ahead and dive right in, right? So the first thing that we need to understand if we want to even approach the topic of, Ethereum smart contract development is what is a blockchain, right? Ethereum is in fact a blockchain. It differs from, Bitcoin in the sense that it introduces this idea of a smart contract and this ability to create software that will run within the blockchain. So I'm not going to spend too much time on this slide. I will point you in the direction of this video here, 3 blue, 1 brown. If you haven't seen his content, it is world-class, amazing. This video right here gives a great explanation, a high-level explanation, and actually some deeper level explanation of how a blockchain fundamentally works with the focus of Bitcoin. And Bitcoin was really the first blockchain that we've seen, right? And it really is just it keeps track of a balance for a given account, right? So it's keeping this single state for each account and how much Bitcoin you hold within that account. There isn't this concept of a state machine to be able to change that state using software. It's just really transactions that say take from this account and deposit into this account, right? But the idea of a blockchain goes far deeper than that. This idea of, building on blocks from previous blocks using cryptography to prove that, everything is in the state that it should be in. And how do all of the distributed pieces of software on the internet basically come together and agree on that given state, right? There's different consensus algorithms that exist to be able to make that happen. Both Bitcoin and Ethereum use currently the proof of work consensus algorithm. Not going to go too much into all of those aspects, but I encourage you to kind of dive into some of that as well. So, understanding what a blockchain is pretty important to approaching Ethereum, right? But that brings us into this idea of Ethereum. What is Ethereum? So kind of like I said before, Ethereum builds on this idea of what Bitcoin established initially, right? So we have this idea of an account, and that account can have a balance. And on Ethereum, that balance would be the native token of Ether. We'll talk a little bit about what Ether actually is in a little bit. But on a fundamental level, it does the same thing that Bitcoin is doing with, the idea of having an account, and then that account can have a balance. But in addition to an account, there could be a contract address. And now within that contract address, we can deploy software. And that software can be designed to manipulate and change balances and really more generally state within its contract right on the blockchain. So what Ethereum really is at a fundamental level, it is we call it the EVM, or it's a virtual machine. So folks that are listening to this that are familiar with programming languages that compile to a bytecode, such as Java, right? Java uses the JVM, the Java virtual machine, in order to execute its code. And it's one of the things that made it so that it could, write once, run anywhere concept that was like the big push when Java was really growing. The reason why that's the case is because there is this layer, this software layer called the virtual machine that interprets this bytecode and executes it in a certain way. Now, Ethereum was pretty much defined within this founding paper that we call it the yellow paper. And if you're interested in really interesting maths and all of the intricacies to the core design of Ethereum, I would encourage you to dive into this. It's pretty in depth, but fundamentally what it does is it defines a collection of opcodes or operation codes that we can use within the EVM itself in order to change the state of the actual blockchain, right? So what are some of those opcodes? If you scroll all the way down the yellow paper, it starts to list these out. So you can see the opcode value in hex, the mnemonic here, and kind of just human readable here, and then it'll have a little description on what it does. Some of the descriptions are a bit technical, but this is basically what the EVM is. It is a collection of opcodes, operation codes that we can use in order to change the state within the system. So that's super interesting, right? So now we have this distributed piece of software. Now this yellow paper just kind of defines the spec, right? So there are many different implementations of this given spec, right? So if we look at implementations of Ethereum, right, I could just quickly do a search here of the EVM. We'll see that, well, that didn't really come up with anything. We'll see that there is a bunch of different implementations, right? The most popular currently is Geth, but there are a bunch of different implementations of this EVM. Now, this is fundamentally what Ethereum is. It's a bunch of people all over the world running these pieces of software. We call them nodes. And these nodes are peer-to-peer pieces of software that implement the EVM, and they communicate with peers on the network. So you can think of this as kind of really a distributed computing platform, right? So it's all these different pieces of software coordinating together to agree on a single state. A single state. So my account has this balance, your account has that balance. This piece of software should execute and do step 1, step 2, and step 3. It's fundamentally what it is. Now, because it's this distributed computing platform and the EVM defines this list of opcodes, there is computational workloads that need to execute when we execute this software, right? If I run a piece of software on my local machine here, say like the browser that I'm in now, it is taking up resources on my machine, right? My CPU is executing instructions. My memory is taking up space. There's probably data being read and written to my disks. That's all resources that are being taken up. Now, in order to get all of these nodes on the network to execute this code and execute these opcodes, we need to incentivize the network with something we call gas. Now, gas is the cost to execute these given instructions, right? And the entire ecosystem is driven by this idea of every block has basically fixed space, and we're all bidding to get into those blocks. So the price of gas changes over time as the network is congested and or if the network isn't congested. Lately, it's been always congested and gas prices are through the roof. So you can always look at gas prices through various different sites, but you can see as of this recording, the gas price is at what's called 194 GWE. So GWE is a unit of measure of ETH. Right, so ETH is the top level native currency of Ethereum. GWE, and even lower down the stack, WEI is saying like a penny if you're talking about US dollars, right? It's the lowest denomination of ETH that you can have. GWE is 1 billion WEI, right? So it's this whole new terminology that we need to kind of understand in order to interact with these networks and develop software for them. So a single WEI is 10 to the negative 19th of an ETH. So it's a very small denomination of a single ETH. And when we're talking about the price of gas, we usually refer to it in gwei, or billion wei. Now, each opcode on the network, you can see here through this reference, each opcode has a specific gas price. So every single instruction correlates to some type of cost in gas. Now, I mentioned before that, we're incentivizing folks to execute this code, and that is part of it in a sense. I mean, we can get into some of the mining operations, which is a little bit different. But I think more importantly is that this enables us to have what we call a Turing complete system, right? And we could go into all the intricacies of what that actually means, but basically it means we can write programs that have loops within them, right? And if we have programs that have loops within them, any of us that have spent time developing software know that if we have loops, there's a possibility to have infinite loops where we have a bug in our software where we continuously run a piece of software and it will never stop executing. So there is a fundamental problem within computer science called the halting problem. And it's a problem that Alan Turing himself actually came up with during this development of a Turing machine. And it's super interesting to kind of look into, but it basically states that there's no way to tell whether or not a given program will complete, in a very simplistic way to put it. So by introducing this concept of gas, it enables us to really put a limit on that and kind of guarantee that there will not ever be any endless loop programs to take down the entire system, because you'll simply run out of money, right? It won't enable you to do that. Unless, even if you had all the money in the world, you're just going to waste it on running a program forever, right? So that's why when we get into transactions and how do we actually set the gas limits and the gas price when we actually start to use these smart contracts, this is going to become very important. And this is why I want to stress this early on in this curriculum, because I believe understanding this will really help us conceptually understand some of the unique challenges that we need to face as smart contract developers as we start to see, how do we deploy software? It's a very different process or different workflow than you may be used to as a traditional software engineer, where we can have more traditional infrastructure to deploy to. So this is kind of an aspect of this world that really excites me. It's super interesting how some of these solutions came up from some of the problems that existed in trying to deploy this kind of ambitious system. So with that being said, fundamentally we have this series of opcodes which enables this computational programmable system to emerge within Ethereum itself. It's all running in these distributed pieces of software we call nodes on the internet that are communicating together to agree on some type of state. And this kind of leads us to ETH, right? And I've kind of went into this already with the idea of ETH is the native currency of Ethereum, and ETH fundamentally is a token that enables us to pay for computation on the network, right? So there's a lot of talk of is Ethereum a currency? And I think in many respects it is, but it's not a currency that maybe we would traditionally think of, like I'm going to go and buy milk with ETH. No, I'm going to buy computational resources on the Ethereum network with ETH. That's what it fundamentally represents. It's your ability to execute code, in this case, smart contracts, on the Ethereum network. So by holding ETH, you hold computational potential, basically, to execute code on the network. And that code could be, calling into an NFT contract and saying, I want to buy an NFT. You're changing the state of that contract to say, you are now the owner of this given token, right? So that's fundamentally what Ethereum is, right? So I kind of just said that, right? Why does it exist, and is it a currency? So if we want to put this simply and kind of wrap this up a bit, simply put, Ethereum is a distributed, global, public, permissionless computing platform. There's a lot of words there, but I think it is exciting that, this is even possible. And Ethereum isn't the only one now, right? We have a lot of other blockchains emerging that employ this idea of smart contracts and being able to execute code within this distributed computing platform. It literally is a world computer. So I don't know about you, but that excites me to the nine, right? There's a lot of there's a lot of scams going on. Absolutely is, but there's a lot of potential here for really, really groundbreaking technologies to emerge. And we're kind of seeing that happen before our eyes today, right? So, which is kind of what excites me to put this content out into the world. So I'm going to stop here. I think I'm on about that 15-minute mark. These first couple may be a little bit wordy, but I want to really put it out there and hopefully spark some of your interest in diving a bit deeper into these fundamental concepts. I'll put the links to everything that I've pulled up here in the show notes. And, you can even, if you wanted to take it a step further and see some of these opcodes in action, very quickly, I'll show you real quick. If you go to OpenSea, right, we'll look at a popular NFT contract, and let's pull up, say, CryptoPunks, right? Everyone loves CryptoPunks. So we'll pull up, it's all one word, if I can type, CryptoPunks. And okay, so we see the OpenSea landing page. Let's go into one of these tokens, this guy right here. And we'll go into details. This is the contract address for CryptoPunks. So I'm going to click this. This is going to take us to Etherscan. Now, Etherscan is a web application that basically aggregates all the activity that's happening on the Ethereum blockchain. And we can look at specific addresses, be it a regular account address or a smart contract address. In this case, we're looking at a smart contract address. So we can see that CryptoPunks is holding about 9,000 ETH, which is equivalent to about 29 million in funds today. And if we go into the contract, you can actually see the source code for this contract because it is validated right within Etherscan. But if we keep scrolling down, you can actually see the bytecode here. And we can switch to an opcode view. And here we go. Here are all the opcodes that make up the CryptoPunks contract. And all of these opcodes will correlate to all of the opcodes within the EVM itself. And you can see exactly the correlation between what the EVM is to how the software is laid out and developed and essentially executed right within the blockchain. So this is crazy powerful stuff. We're going to get into a ton of this stuff. We're going to really dive into Solidity. So really understanding how to write code that looks like this, how to compile the code, how to deploy the code. And yeah, I'm looking forward to it. It's going to be a lot of fun. So any comments, suggestions, please leave a comment below. And if you're liking this, please subscribe. All right, guys. Thanks.